In this exact area of the ocean, thousands of ships pass every single day. Cargo ships, passenger vessels, military aircraft. And yet, we're told this place swallows them whole. No wreckage, no explanation, just mystery. But what if the mystery isn't real? What if the only thing disappearing is logic? What if the Bermuda Triangle isn't dangerous at all, and the numbers prove it? The Bermuda Triangle isn't just a story about ships and planes. It's a story about how humans misunderstand statistics. For decades, this region has been described as unnatural, cursed, defying physics. But today, we're not interested in legends. We're interested in data. Using real accident records, global shipping traffic, insurance statistics, and basic probability laws, we're gonna measure this myth. Not to debunk it emotionally, but to dismantle it mathematically. Because when numbers are applied correctly, some mysteries don't deepen, they vanish. The first mistake people make is looking at raw numbers. Yes, ships have gone missing in the Bermuda Triangle. Yes, aircraft have crashed in this region. But here's the part almost no one mentions. The Bermuda Triangle is one of the busiest maritime corridors on Earth. It connects the east coast of the United States, the Caribbean, South America, and transatlantic routes to Europe. Thousands of vessels pass through this area every single day. And when traffic increases, incidents become more visible. Not more frequent, just more noticeable. Think of it like this. A single car crash on a quiet rural road feels shocking. 10 crashes on a major highway feel normal. Not because highways are more dangerous, but because millions of cars use them. Risk must always be measured relative to volume. When incidents are calculated per ship, per mile traveled, per year of traffic, the Bermuda Triangle does not stand out. In fact, statistically, it performs better than many less famous ocean regions. So if the numbers are normal, why does the legend survive? Here's a simple rule. If a place were truly dangerous, insurance companies would know before anyone else. Because insurance doesn't run on fear. It runs on risk models. Lloyd's of London is one of the largest maritime insurers on the planet. They insure routes across every major ocean. And here's what matters. They do not charge higher premiums for ships crossing the Bermuda Triangle. Routes from New York to the Caribbean cost the same as routes in the Mediterranean. Roads through the Triangle cost the same as routes in the Pacific. If the Triangle were statistically dangerous, it would be priced accordingly. But it isn't. Because the data doesn't justify it. Money doesn't believe in myths. It believes in probability. And the probability here is ordinary. So if the data doesn't support the myth, why does it feel so real? The answer is psychological. Once a myth exists, the human brain starts working to protect it. This is called confirmation bias. We notice information that supports the story and ignore information that contradicts it. When a ship sinks outside the triangle, it's an accident. When a ship sinks inside the triangle, it's a mystery. Same event, different label. Disappearances like these happen all over the world, in the South China Sea, in the North Atlantic, near Japan's so-called Devil's Sea. But without a famous name, they don't become legends. The Bermuda Triangle doesn't create anomalies. It collects attention, and attention changes perception. But perception alone isn't enough to explain everything. There's real danger in these waters, just not the kind people imagine. There are no portals in the Bermuda Triangle, no magnetic gateways, no spatial anomalies. There's only physics. This region is known for sudden storms, rapidly shifting weather systems, and rare but powerful rogue waves. Rogue waves aren't tall stories. They are measurable phenomena. When multiple wave systems collide, their energy can combine into a single, massive wall of water. In laboratory simulations, these waves have been shown to destroy large vessels in under 3 seconds. No warning, no time to react. Add shallow water, strong currents, and unpredictable weather, and accidents become inevitable. Not mysterious, just unlucky. When these events happen in a high-traffic zone, they feel supernatural. In reality, they are statistical outliers. Rare, but expected. So where did the legend come from? Not ancient sailors, not secret knowledge. Publishing. In 1974, a best-selling book popularized the modern Bermuda Triangle myth. It combined real accidents, exaggerated reports, and events that never happened at all. Some ships listed as missing were later found safely docked. Others were not even inside the triangle. Coordinates were stretched. Timelines were altered. Not to deceive maliciously, but to sell a compelling story. And it worked. The myth became a brand. Once the story spread, the numbers stopped mattering. Because myths don't survive on data. They survive on repetition. So let's measure what we've learned. Heavy traffic creates visible accidents. Insurance data shows no anomaly. Psychology amplifies coincidence. Physics explains the danger. And marketing created the legend. The Bermuda Triangle isn't impossible. The belief in it is. If you prefer data over drama, subscribe to Measured Myths. Because the most fascinating mysteries are the ones